Okay, welcome back to our part 4 of our series where we're going to start talking about UVGI and how could it help improve our indoor air quality. Des and Ray, how are you doing today? Good?
Good.
Very good, thank you.
So I wanted to, before we dive into the questions, I wanted to just ask a little bit about UVGI, what it stands for, how it can help. So take it away.
So UVGI, ultraviolet germicidal eradication. And really what it does is it kills bacteria and viruses when you use a UVC lamp that can radiate a surface. So that radiation, the energy from the lamp, kills and destroys the viruses. Pretty simple. And when you think about it, it does a great thing. How does it help? It helps us by anything that it can shine that light on, it can kill it. So there's a lot of different variations of how we can apply it, and we can talk further as we answer these questions.
Awesome. First question of the day. Who typically uses UVGI and what was the initial intent?
The initial intent for UVGI was way back in the 70s when Legionella first raised its head at cooling coils and in drain pans in AC systems. And what they found was UV light was very effective at killing the Legionella virus on the surfaces. So what they did was they developed systems to remain permanently in the coil, at the coils and in the drain pans, so that eliminated the Legionella virus.
Very interesting. All right, the second question of the day. During the dry season, when it's not dehumidifying, is pass-through at the UVC cooling coil a concern?
I think the idea is that if the radiation from the lamp kills the virus has to be sitting on the coil. In the cooling season, when we're doing dehumidification, it is actually caught by the moisture on the coil, so it has more residence time to kill the bacteria or viruses. When we're not in dehumidification mode and the coil is dry, the air passes straight through the coil, doing what it's supposed to do, which is create colder air, in which time it's not as effective at killing the virus because it doesn't have enough time to radiate the bacteria or viruses as it passes over the coil.
Yeah, so UVC light needs exposure time and it needs intensity to kill bacteria and viruses. That's why it's effective during the dehumidification mode, because the viruses which are riding on other dust particles and dander and other stuff in the air adhere to the surface of the coil, and that gives the UVC light exposure time, and the intensity kills whatever's on the coil.
So if there's less heat, it's less effective.
There's less moisture on the coil. It's less effective. The drier the coil, the less the dust particles are going to adhere to the surface of the coil, so it is less effective.
So radiation or residence time is what creates the effectiveness. So if there's less radiation time or residence time, then it's less effective.
All right. How much does it cost to upgrade existing units with a UVC system?
For typical 20 to 30 ton DX units sitting in a mechanical room, equipment cost is around between 4,500, 7,000 to 8,000, depending on the configuration of the unit. The installation cost again varies from region to region. Really, the labor involved is just finding a circuit to connect the UVC system to, and then the actual installation. So, on average, probably between $10,000 to $14,000 per unit installed.
How much does it cost to add UVC to a unit during manufacturing?
Well, it's a lot less, obviously, because you're not retrofitting. So the equipment cost for retrofit is between $4,000 and $8,000. So the additional cost to install it during manufacturing is probably within that range, $4,000 to $8,000.
So the next question I feel like is going to be a big one for you guys, and it is, why shouldn't UVC lamps be used in ductwork?
So we talked a little bit about how the UVC lamp kills viruses and bacteria based on its distance and time of exposure. And the reality is, in a duct, you need to have a really long duct with a lamp all the way along that long length, or multiple lamps along that entire length, to create that exposure time. So as the air passes through a duct at, say, 1,000 feet a minute, you can imagine that there's not a lot of time for that radiation to kill the bacteria or virus. So there's large challenges with the ability to install it in a duct. A lot of those challenges are based on the linear length of duct that's available in a building. Most buildings don't have that length of straight duct available. And then the other problems you will encounter if you go down that road will be things like service. You have to have an access panel every couple feet in that 50 to 100 foot length of duct, and you have to clean the actual lamp every month. You have to service the lamps and replace them every 6 months. Over time, you're going to have a lot of maintenance concerns. Ductwork leaks. Your access doors are going to leak. They're going to whistle. They're going to make noise. So in the long run, you'll end up with more issues related to putting that type of system in a building than you would get benefits. So for those reasons, we're not looking at recommending that in most cases. There may be an application where it's applicable, but in most cases, there's more challenges than there are benefits. There's better ways to combat indoor air quality issues or COVID-19 issues.
Good to know. We don't want more issues during this time. All right, next question. Is generating ozone from UVC a concern?
No, not really. The background to ozone is that it does cause long-term health issues. Systems from a couple of decades ago, which were under the umbrella of Corona dumping ozone into the space that it was serving. They soon discovered that it was causing health concerns. So that's why any systems that do create ozone are not recommended for space. The amount of ozone coming off a UVC system is minute, and the UVC system is endorsed by ASHRAE, who are industry standard, and there's no issues really with ozone from UVC.
So just to add to that, Des, and we've done some research on some of the older products, there are UVC lamps that generate enough ozone that exceed the EPA threshold of 0.05 parts per million of ozone in a space. Obviously, those are fewer and farther between, but when applying UVC lamps, we should always consider verifying that those lamps do not generate that ozone. It's just a safety check, and in our designs, we do that check every time.
I was like, yikes, as soon as I heard health issues. So thanks for clarifying that. Okay. Next question. Why are UV lights not recommended in occupied space or office environments?
Because the type of UV light that's used, which is a UVC light. UVC light is the ultraviolet light that's filtered out by the ozone layer in the atmosphere, so it doesn't make it down to the surface of the Earth. The other types of UV that we deal with typically are UVA and UVB, which in our atmosphere here, and they're the ones that give us we stay out long enough will give us a tan or a sunburn. So the UVC light can cause long-term health issues, including skin cancer, and can cause damage to the retina if you look at it. So it's not recommended to be used in occupied spaces.
I think the real challenge a lot of people don't think about is light doesn't go around corners and it can't get through surfaces. So if you put it in an office space and you expect it to clean the space completely, you're giving people a false sense of hope. And sometimes a false sense of hope can be worse than hope itself. So for those reasons, we're really not recommending it. We don't want to give people the perception or the understanding that they're perfectly safe after they've turned those on. And the reality is they're not.
Well, when I think of UV light, I just think of those tanning beds. And then now that you're mentioning skin cancer, I'm like, oh, wow. So it's kind of making sense. And I know we touched on this earlier, but for those of us who haven't caught the breakdown of how UV kills viruses like COVID-19, please share with us how that is.
UVC systems work by radiation. So UVC light is short wavelength ultraviolet light on the light spectrum. And basically what it does, it breaks down the viruses or the bacteria, basically cooks them over time. So that's why the exposure time with UVGI systems is really, really important, because it gives time for the UVC light to really break down the particles and kill them. So that's how it works.
Ray, would you like to add to that?
My only point would have been that, I think it's 265 nanometers is the ideal wavelength that radiates the surfaces and the bacteria. And at a molecular level, it just tears it apart.
All right. Thank you for joining us. Next time, we're going to talk about PCO and ionization, so stay tuned.